Right. So the question is, this is another question on Bayes' theorem, and the setup is that we have a box, right, and it's got three shelves. Let's call them A, B, and C, and each shelf has coins in them, and the coins can either be gold or they can be silver. They don't have to be all gold or all silver. They could be one gold and one silver, but they are at least, but they're all either gold or silver. And what we've been told is that in shelf A there are two gold coins, and in shelf B there are two silver coins, and in shelf C there's one gold coin and one silver coin, right? And we are told that one shelf is picked at random, and from that shelf a coin is picked, and that coin turns out to be gold, right? So what's the probability that the coin came from shelf A? So what's the probability it came from A? So if I were to write the probability expression for this, what I'm looking for is the probability that the coin came from A given that it's a gold coin, right? So this is the probability I'm looking for. Now there's some obvious questions, right? So what's the probability that a coin came from shelf A? Well, that's just the probability that shelf A was picked. So if you open shelf A, you take a coin out. And what's the probability that shelf A is picked? Well, that's just 1 by 3. We said each shelf has an equal chance of being picked. The shelves are chosen at random. And this is the same, and therefore the probability that shelf B is picked is also 1 by 3, and the probability that shelf C is picked is also 1 by 3. So this much is obvious. Now the next question is, what's the probability of getting a gold coin given that shelf A was picked? Well, shelf A has two coins in total, and both of them are gold. So if you pick shelf A, you're guaranteed to get a gold coin. So probability is 1. The probability of getting a gold coin if you pick shelf B, well, shelf B has two coins. It also has two coins, but they're both silver. So there are 0 gold coins inside. So if you pick shelf B, you have a 0 chance of getting a gold coin. And the probability of getting a gold coin if you open shelf C is, well, shelf C also has two gold coins, but only one of them is gold. So the probability is half. So we got this also. So we've written the probability expression for that. But what we are looking for is the probability that the coin came from shelf A given that it's gold. And what Bayes' theorem tells us is that that would be equal to this expression over here, right? So this is the expression that it evaluates to. So if we know these three terms, then we can find out the value probability that we're looking for. And actually, if you look at it, we do know most of what we are looking for, right? So in the numerator, we know what the probability of getting a gold coin given that the coin comes from A is. We just wrote that down over here. So that's this over here. And the probability of A, well, we got that over here. So the only thing that is left to be found is the probability of actually getting a gold coin, right? So the total probability of actually getting a gold coin. So if I were to, let me see, I can scroll down. So the probability of actually, so the only thing we need to calculate is this, and the probability of getting a gold coin is the probability of getting a gold coin if you pick A into the probability of actually picking A, plus the probability of getting a gold coin if you pick B into the probability of actually picking B, plus the probability of getting a gold coin if you pick C into the probability of actually picking C. Now again, you would notice that we know values for each of the terms in this long expression over here. So what's the probability of getting a gold coin if you pick A? Well, A had two gold coins, so we are guaranteed to get a gold coin if we pick A, but the probability of actually picking A is 1 by 3. Plus, what's the probability of getting a gold coin if you pick B? But B has no gold coins, so 0 chance, but the probability of picking shelf B is still 1 by 3. Plus the probability of getting a gold coin given C is 1/2, and the probability of actually picking shelf C is 1 by 3. So if I just add this up, this is equal to 1 by 3 plus 1 by 6, and this turns out to be half. So we got the last missing piece in the expression over here, and if we just plug in the values, then probability of A given G is actually equal to probability of G given A is, I always forget the values, it's 1 multiplied by probability of picking shelf A, that's 1 by 3, divided by 1 by 2, and this turns out to be equal to 2 by 3. So you can do this calculation on your own. What I really wanted to focus on instead was the Bayes theorem part of it. So this answer to our question is 2 by 3. The probability that the coin came from shelf A is 2 by 3.